our first group will be strengthening of RC beams with the CFRP laminates. Will we start?
Okay, good evening everyone. First I'd like to introduce our group. I'm Walid, Amina, Muhammad, Murad, and Mom. Okay.
العكس
ايوه
As Dr. Sharif stated, our topic will be strengthening concrete beams using CFRP. For those who don't know, CFRP stands for carbon fiber reinforced concrete. This is a brief outline of what our presentation will be like. First, we're going to give a little background about the topic. We're going to state the types of FRP in the market, the problem that we're facing and we're trying to solve, of course, the objective that we want to solve, the different methods we'll be able to use in the project, the outcomes that we expect will happen, and of course the time frame we'll be working in throughout the semester, and of course the references and if there's any questions. Okay, so in the construction industry in general, FRPs have been used for about 20 years or more. They have two main applications. The first is strengthening and the other is repair, or both together. FRPs, they're available in Egypt, of course, in two companies, mainly CENG and us. We chose CFRP, the carbon fiber reinforced polymers, over the others for these reasons. Okay, so we have three main types of fiber types. First is carbon, and there's aramid, and there's glass. There are certain criteria that we want. The first is the tensile strength, of course, the modulus of elasticity, how it will behave in the long term, also how it will behave for fatigue, the bulk density, and how it will resist alkaline or chemicals, and of course the price. As you can see, carbon is practically the best.
Okay, for the problem statement, the traditional way to strengthen a member is by fixing the CFRP laminate at the bottom of the beam. But when the beam begins to experience failure, small cracks are formed from the middle of the beam all the way down until it reaches the epoxy layer, at which the bonding fails and the laminate falls intact with all its strengths and properties. So our scope is to examine the strengthening effect of CFRP laminates, to try alternative ways to reduce the debonding caused by the cracks, to compare between our different proposed methods and find out which one is the best, and to relate our experimental analysis results to the code provisions. We will be using 10 beams, 3 meter long, 0.2 by 0.4 cross section. The concrete strength will be between 25 to 30 megapascal. The strips, CFRP strips, will be bonded in different configurations, and we'll cure the beams for 28 days, and then test them in the flexure to failure, and determine the effect of CFRP laminates strengthening on the beams. 9 concrete cubes will be poured in each cast, and tested after 7, 14, and 28 days.
As we said, we're going to be pouring 3 meter beams. We're going to be pouring 2 beams per day. First, we're going to start by pouring 2 beams without attaching any CFRP to it. This will act as our control experiment. Then we will make 2 more beams, and we'll do it with what is considered the traditional method by attaching 2 CFRP laminates at the bottom. Then we will be trying different methods than the traditional to see if it will give us better results, to see if we could delay the load at which the epoxy layer is going to fail. The first method we're going to use is by trying to attach the laminates on both sides of the beam instead of at the bottom, because usually the cracks are going to spread to the bottom of the beam, and it will start spreading horizontally through the epoxy layer, and that will make the CFRP fail before its actual load limit, because the epoxy itself is going to fail. So by attaching to the side, we're hoping we're going to delay the time at which the cracks are going to spread into the epoxy. Then after that,
in addition to what Mohammed said, we're going to also have 2 alternatives. The first one, as you can see in the picture, we're going to put the CFRP laminates on the soffit of the beam. In addition, we're going to add the CFRP strips on both sides and anchors. Also, the last alternative we're going to do, we're going to put the CFRP laminates on both sides of the beam. In addition, I'm going to also add the CFRP sheets act as anchors. Our expected outcomes or what are going to benefit from this. First, we would like to, we expect to see a delay in the crack-induced debonding failure in the CFRP strength beams. We're going to also investigate the strain limit imposed on the CFRP strips and account for their premature failure on the debonding failure. What we're going to benefit from this project? First, we're going to be working on full-size beams in full-scale tests, and we're going to obtain results and do reports. We're going to also meet new contacts in the construction industry, like suppliers and companies like CENG and BUS.
Well, this is our new updated schedule for the weeks that we lost. We already done the 3 weeks the research. We are already done with the design of the beam. The material procurement, we already made deals with suppliers. We paid deposit. Our material is going to be cement, steel, carbon fiber. Putting the beams on the tubes is going to take about 2 weeks. And securing the concrete is going to be directly after the pouring, and going to take about 1 month. Then attaching the carbon fibers directly after the pouring. Then testing the first set of cubes after really directly after the pouring, 7 days, 14 days, and 28 days. Then testing the beams after attaching the carbon fibers. Then we have the results for the last 4 or 5 weeks, then finalizing the report. And our recommendation for the groups who are interested in our subject, maybe later, is to put the anchors at the edges of the beam, and instead of using, put the anchors at the ends of the beam, and instead of using the epoxy, and see and compare between the strengths between each other. This is our reference. Thank you. Any questions?
You made a very good start for the 490. I'll just say very few quick comments. I don't have real questions. Your key advisor is Dr. Aizzi Yazid, and we humbly helping. Dr. Sheikh Safar also has a very good experience in this field as well, so I'm saying that so we can use this help whenever needed. I want you and all the other groups, particularly the ones working on materials and things that require lab work, to revisit their schedule after Sunday, in case, heaven forbid, there is a delay and so on. The reason I'm saying that, and I said that to you when I met with Dr. Aiz, is that to the best of my knowledge, you are the first group in 490 ever to make large beams. Okay, for benefit of fact, inshallah, but all I'm saying, if you don't need just a small lab, you need a large lab to do that. So just revise your schedule after, by this weekend, things will be hopefully clear. You want to say something?
No, we already not back ولا أي حاجة. We are on schedule حتى لو week فاتنا we already on that.
Yeah, but my point, if you can't, that you couldn't get into the structural lab, and we're going to use small laboratories where you can't make large beams. So just, inshallah, we wouldn't resort to that possibility, but I'm saying I wanted to revise your schedule in light of what the coming few days will bring. Inshallah.
Okay, I have some technical comments. I mean, the presentation is very good. We thank you for that. But please take care of the span, because you didn't mention anything about the span of the beam itself. Such that you have moment failure. And also the loading. Are you going to put concentrated loading?
Yes, concentrated loading. No concentrated loading in the middle.
Okay. Regarding also the initial design, are you going to put reinforcement less than what is supposed to be there?
Normal reinforcement, but weak mix. Our mix is going to be from 25 to 30 megapascal. That's low.
And the design itself, we removed all the safety factors.
Well, I would advise, if you would like to think of that a little bit, when you are putting CFRP, you are strengthening the reinforcement. So the reinforcement should be initially weak, so that you can get something out of the results. If the concrete is the one who is weak, then you might get crushing failure, not failure at the tension side. So I would rather think of making the enforcement the one because the CFRP is helping the enforcement, right?
Yes.
So you have to make the enforcement less.
We did minimum reinforcement for that type of beam. Minimum reinforcement with weak concrete.
Okay. Very good topic also if you would like to think of applying some sort of cyclic loading to see the effect of fatigue, the different, when the load value is changing, this might have an effect on the epoxy. So it is also a very interesting topic. You can use the same beam, you can apply cyclic loading, service loading, and then after that you can crush the beam up to failure. So you're doing two tests for the same specimen.
Sharif, I want to share with you and with the friends here something. This morning, coincidentally, I received an email that the group who worked 2 semesters ago, Michael Agaibi and his colleagues,
Yes.
worked with FRP and made a very good presentation. Their work has been accepted this morning to be presented in Washington, D.C., inshallah, January 2013, unless they close the campus over there.